Today, we'll be talking about forces. Intra versus inter will be the first subject. Now, intramolecular forces are the forces within a molecule, such as we have hydrogen bonded with an oxygen and another hydrogen to make water. Over here in the intermolecular forces, we have a water molecule bonded with another water molecule.
Now, from IMF, for strength-wise, from least to greatest goes metallic, covalent, and then ionic. Now, from there are three subcategories for covalent, one of them being LDF, which is London dispersion force. Now, London dispersion force is caused by the electrons around or moving around the nucleus. And it is the weakest of the covalent type bonds. Next is dipole-dipole. Now, in comparison to LDF, dipole-dipole is stronger in means of strength. Now, dipole-dipole can only be there if the compound is polar. Now, for those of you little weasels that don't know what polar is when the compound has either loose electrons in per se a Lewis dot structure, or if it is asymmetrical in means of the elements around the center. Now, last is hydrogen bonds, or H bond, whichever you want to call it. This form is the strongest of all covalent type bonding. And H bonds only appear when there's a hydrogen bonding to either fluorine, oxygen, or nitrogen. Now, a simple mnemonic, for those of you that have trouble remembering this kind of thing, Miss Harvey came up with something called hold the phone. Take out the H and the FON.
Intermolecular forces have many different influences on different variables, such as IMF increases, it can have the effects of the following. increase in surface tension, an increase in viscosity, which is basically the thickness of something such as mud or silly putty. That's a Y. Increase in melting point, increase in boiling point, and a decrease, yes, it's a down arrow, in vapor pressure.